moves.
Talk about cherry picking. Einstein, I sit there and said he could not, every single terrestrial experiment he did or looked at could not actually prove that the Earth was stationary. That's what he says.
He was talking about experiments where you're measuring changes in acceleration and velocity and position.
No,
where you're in your little spaceship trying to measure how you're moving. That's the kind of thing. There is relativity. You can have different reference frames, and what Einstein said, and is correct, is that the laws of physics are the same in these different reference frames. That's what he said. That was so revolutionary.
What's the law of physics of water? Oh,
gravity.
It maintains level.
Okay, we've got a whole lot of material to cover. Can we? I gave you a chance. Can I try to?
Same thing. Stellar aberration.
Stellar aberration.
Assumption.
But you have to tilt the. No, this is actually measured. That 20 degrees or minutes of arc is measured. 20
assumption. You can't use assumptions to call them fact.
20 seconds of arc.
You can't use assumptions to call them fact.
But these are not assumptions. These are measurements. These are measurements that we have to correct the angle of the telescope to see the light. That's a measurement, right?
I can't argue if you're going to sit there and just deny that it is an assumption. It is an assumption. You can at least admit it.
I can't argue if you're going to say that a measurement is not a measurement.
Because one thing you'll say is an assumption.
It's a measurement.
You say it's true.
Okay, Coriolis, the Coriolis effect. There it is. There's the equation for it.
No way, proven.
And guess what? The guys that shoot guns.
No, they don't. Here,
yes, they do. This is from thetruthaboutguns.com.
A sniper manual from the Marine Sniper.
Okay. Can I just make my points? You had an hour to make your points.
Until you know.
There it is in black and white. Yes, long-range shooters have to take the Coriolis into account.
You're lying.
I got this off the internet. I am not lying.
Wait a minute.
This is a legitimate gun marksman site.
The range snipers fire at the Coriolis forces Coriolis effect is negligible. But the range at which artillery fires, it is not negligible.
Okay, for these expert marksmen, 1,000 yards, they're getting a 3-inch difference. That's enough for these expert marksmen to care. Yeah. They care about it. It's a real effect. Let's move on. It's a measured, real effect. Okay, here's a good one.
You're not going to let me comment on it? I can stand and show you right now that I got it right on this laptop that shows you a Marine sniper manual from the Marines, straight from the Marines, United States government. There's not one mention of the Coriolis effect in the whole manual. Why is that?
Because maybe they're not shooting over 2,000 yards. And in ballistics, you really do need to take Coriolis into effect.
How come my helicopter, when it lifts off the ground, the earth don't spin underneath it?
Because of air. The air goes along with the earth. Why, when Hurricane Harvey was sitting in Houston, Texas for 2 weeks, why didn't that hurricane come around the earth every day? Because of the air goes with the earth. Here's a question I'd really like to answer.
That is a hard one. I can see that. That is a good one.
That shows the North Pole, or the Polaris, the North Pole. The stars are going clockwise. And if you look toward the south, this is an amazing picture. It's a long time picture, so it shows the stars, and it shows 180 degrees. This point here is basically that point there. When you're looking south, you can't see the southern pole star. It's below the horizon, but you can see the stars that are going clockwise around the south. This is something you can do. When we look at the Big Dipper at Polaris, the stars their stars rise in the east and they go down in the west, and they're going counterclockwise. When we look to the south, we see the stars rise in the east, go to the west, and they are going clockwise. This is what we see, and there is no way you can do this on a flat earth. Because
you're assuming a flat earth, I just told you.
I'm assuming the flat earth that you described, that you accepted.
No, because you're saying there's a flat earth theory. No, there's not. I believe we have a celestial ball around us. It ain't a dome. It's a celestial ball. So that explains. If
a celestial ball of stars was rotating around the earth, it would not look like this.
It doesn't matter. How does an EQ mount work on a telescope? What does it do?
It tracks stars based on heliocentric theory.
It's on a celestial ball. It's not based on a circular Earth. It's based on a celestial ball. The EQ mount on your thing is that, and that will give you that too. So that's no excuse.
You can regard the stars as a sphere. That's a way to locate them. It's a handy way to locate them.
And that's what I'm telling you.
What I'm telling you is this picture could not happen on a flat Earth, because you can't have stars going clockwise over here and counterclockwise over there on a flat
It is a celestial
Earth.
ball around us. But the
Let's
sun
move
and moon
on.
are going around us. The sun and moon are.
Gravity, do you think it's real?
No, it's made up. You want to hear? You want to try? Oh,
No, I want to show you this picture. Why is this guy having a hard time walking uphill? And now let's just, for the sake of argument, say gravity is a Masonic hoax, doesn't exist. So I want you to explain why it is harder to go uphill.
Because let's see, force of motion.
What force?
How did gravity?
What's creating the force?
How about buoyancy and density?
Buoyancy and density.
Yes. So if I let off a hydrogen balloon or helium balloon up and it's slow, is that anti-gravity? Is that anti-gravity?
No.
Did I just create an anti-gravity device because that balloon floated in the air?
No, gravity is pulling on it, but because it's lighter, the air is pushing it up.
So is
Okay.
did I create an anti-gravity ball right there?
What a comment over here.
Go ahead.
This is my first time here. I came to listen to this gentleman explain something about how he believes there's a flat Earth. I didn't expect to get two lectures, one from the flat Earth gentleman and one from the
Heliocentric?
Ask a few questions.
and maybe you should have given another presentation to refute this. I think that
That's
I'd
what
like
he's
to have a
doing.
donut, and I think I'd like to listen to some comments from the audience here, and get back to why, simplify. Why do you think, for example, give us a synopsis of why you think the Earth is flat? See, that's now. I'm not asking you to do it now. I'm just saying.
I think I've got some really good questions. I'd like. Can I proceed with them? I have a few more.
See, you're saying you're bringing up gravity when nobody in here, I think, can make gravity been proven. Does anybody make gravity been proven here? Have they found gravity?
Yeah.
Have they
Oh,
found
yeah,
gravity?
sure.
They proved
That's what
gravity.
makes it hard to go uphill.
Who says true gravity exists? Oh my goodness. That's velocity and density to explain that very well. So when I let a balloon go up, like I said, that's anti-gravity. I just created an anti-gravity device by letting the balloon go up in the air.
Okay, I've got a question for you. Well, before we move on, Cavendish, you can actually buy the Cavendish experiment for $3,000. It's a real experiment, and you can measure gravity. I don't expect you to believe that. Okay, here's what you were saying: buoyancy and density. Why does the balloon go up and the submarine go down? If the density is greater than the surrounding fluid, it sinks. So goodbye gravity. So here's a question for you. Here's a scale, and we've got 1 liter of water here, and we've got 2 liters of water there, and they're both water. They're exactly the same density, and they're in the atmosphere, which has the same density. How come this one pulls the scale down?
It's twice as much water as the other one?
But you just said it was density. You just said gravity doesn't exist, and it's simply density. These things have the same density. They should be on the same level, according to what you just
You
said.
have more of one than the other. It doesn't mean what it is. The density is.
Well, you have more mass. That means more weight. That means more force from gravity. Heliocentric gravity explains this.
Gravity to explain why things drop. You don't need a magical gravity. Or you know why you need gravity? And to explain how you can be stuck upside down on a spinning ball of water. That's why you need gravity. Other than that, you don't need gravity.
No, gravity explains why some things are heavier than others. It really
That's why
does.
you need gravity.
Can we go on? Here's a meme that shows how ridiculous it is if we were spinning at 1,040 miles an hour and nothing's happening. When 60 miles an hour, it's like that.
1.9 million miles an hour to that. You don't feel nothing.
Yeah, well, when you actually calculate the acceleration, it's about 1/4 of a g for this, about 12 g for that. Pretty painful. 0.003. The Earth takes a whole day to turn around. We just don't feel that acceleration. This picture is fine.
Add all the other movements that Earth is supposed to be making.
But everything is moving along
You're
with
just
it.
doing the circle. You add every other
Our
movement.
solar system is
It
moving.
wobbles, it turns, it flips, it
through the Milky Way.
It's going 2 million miles an hour.
Okay.
You want to forget all that, though. You just
Real
Come on.
question. I have a real question.
Come on, man. At least
What covers the sun during an eclipse?
Rahu and Ketu, we don't know. Rahu and Ketu. You ever heard of them?
It's a Hindu thing.
Can you prove it's the moon? Can you prove the moon would cover
Actually,
the
I
sun?
can. Actually, some creationists did that. Some young Earth creationists took this picture of the eclipse on August 21st. This is a real picture by young Earth
It's
creationists.
CGI, yes.
And what they did was they let the corona be overexposed. Usually people make the corona exposed right, and that means the sun is a black
Do you know
ball.
Earth has three
But these guys let the overexposure happen, and guess what? There's the moon with its seas and meridian and craters.
You just found one.
No, other people have done this. This I just thought was pretty cool.
How many moons does Earth have?
One real big one.
Now they're saying we have 3. We have 2 dust clouds they are calling moons. You can look it up. NASA's saying we have 3
Okay,
moons.
that doesn't prove that the moon doesn't cause eclipses.
I'm sorry, I didn't get the answer to the question as to what caused the eclipses. What was your answer?
Rahu and Ketu, probably. I really
I don't know what that is. What is
Rahu and
if
what?
you look at ancient cosmology, they say there's other entities up there that we can't see. So basically, they're called Rahu and Ketu. They're shadows. You can't see them. They're just like NASA is now admitting there's like these big cluster balls that you can't see, but they're calling them moons. And they're up there. Kind of like Rahu and Ketu, if you ask me. But they're saying we have 3 moons now.
Okay, but I just want to make sure I understand what you're saying.
Yeah, it's Rahu.
I just want to make sure.
It's R-A-H-U and Ketu, K-A-T.
So
Look up Chinese
what's
mythology.
causing the shadow?
They eclipse the sun. They eclipse the sun. The Rahu and Ketu. I guess it's a round body. You have to get more into the mythology, and it's not as big.
So it's something mythological.
It's a brown mythological body.
It's their cosmology. That's what they believe. That's what they believe. They believe this entity or another object called Ketu or Rahu that you couldn't see.
So it only appears during eclipses?
Exactly. It only eclipses the moon and the day. Yes, exactly. Eclipses the sun.
I'm going to go with the creationists on this one.
But like I said, look up the downstream NASA, and that's the same. We have 3 moons.
I just want to-
Put that on there. Yeah. Check it
Okay.
out.
So here's another question. I've just got some questions I'd like to get out there. Octans, the southern pole star, the equivalent of Polaris or northern pole star.
One that never moves.
How come people in South America can't see Polaris? And how come, and where would they look for octans? You can see, if this is the flat Earth map, they'd be looking in different directions for the same.
Who was it that was in Antarctica that reminded me? Somebody said, Dave here, can you please get us some 24-hour sun footage from Antarctica?
Oh, there's plenty of it. But you guys say it's CGI, so what's the point? Let's move on.
We need more. See, you just want, because there's only like 1 or 2.
Oh no, there's dozens and dozens, and as many as I find, people say, well, CGI, let's move on.
You went back, don't lie.
Southern Cross. How come I've never seen that in my lifetime?
And then southern equator.
But it's
It's called the
my friends in Australia, they're only a few thousand miles away, and they can see it.
Dude, it's going to drop down the horizon so bad to where the angle of attack you can't even see it. But it's still there, but you can't see it because you're too far from it, Dave. Come on. It's the simple laws of vision, man. Come on. It's not with these.
Well, the heliocentric theory has a different explanation. Southern Cross, I can't see it because the Earth is in the way.
Well, because
It's a
your
very
eyes don't
simple
work that far. It
explanation.
drops low in the horizon. It drops
Actually, you can see the northern star of the Southern Cross from Albuquerque at the right time of year and the right time of day. It's not that they're too far away, it's that the Earth is in
How
the
about we do
way.
this there? Dave, I can get on my camera right here. I can go set this I can probably set this piece of paper right here on the ground. Right here. I can get my camera, come back here, and set it down, and guess what? Those papers will disappear on a flat surface. You won't be able to see those papers 10 feet away from you.
I know
Why
about
is that?
perspective.
Why is that?
That doesn't
it's the
explain
angle of
everything.
perspective. That's why you can't see the stars. The same reason why you can't see the piece of paper down there when you should be able to see it on a flat
Here's a simple experiment anybody can do anywhere in the world. If they go out in the evening sky and use the Big Dipper to find Polaris, the elevation of Polaris equals your latitude. So here in Albuquerque, 35 degrees. If you were up in
Once again,
New York, it would be 44 degrees.
Once
In
again,
Canada, it would be like 60 degrees.
So can I ask you once again, why is it when you ask people if the earth is flat, they always got to talk about the stars, the sun, or the moon?
Because-
I'm talking about the earth is flat. Can you prove that the earth is curving and water is sticking and curving?
But this is a way you can prove the earth is curving. Anywhere, any night of the year, people can measure the elevation of the North Star and they can compare it to their latitude. And every time somebody does that, it proves the earth
How
is
does a
round.
universal astrolabe work, Dave? How's that a universal astrolabe? Not the one where you got to switch the things. A true universal, which you'll find very little about. You can sit there and say, a universal astrolabe is one plate that will tell you where all the stars are on an entire freaking hemisphere.
Okay,
So,
you're changing the subject.
no, I'm not changing because you keep talking about the stars, so I'm asking you about the stars. I'm talking about the land is flat. Go out there and measure the curvature. Show
Okay.
me water is sticking and curving around to that ball.
The
You can't-
point I'm making here is that the angle of Polaris depends on your latitude, and heliocentric or round Earth theory
So what?
explains
You just go
that
out
very
there
well.
because you're assuming stuff and you're trying.
It's not assuming. This is something you measure. You can go outside on that ledge and measure the distance of Polaris, and you have thereby measured your
You're doing some
latitude.
math to make it look like you're doing some more math and magic bullshit, and that's what it is. It's math and magic.
It's not even math. You just see the picture when you're by the North Pole, Polaris is overhead. When you're on the equator, it's on the ground. In between, it depends on your latitude. It can be measured. Let's move on.